Good morning. Dennis James here. Want to welcome you to the SQL Server security webinar that we're having. It's a beautiful sunny day here in Seattle, which is unusual for us, but we'll soldier on through for the next couple of minutes. Go ahead, Mike. Next slide. And as you're well aware, there's a lot of challenges with security these days. It almost seems like anybody can break into anything. And we just also wanted to note that in the upcoming year or so, the security market and being involved with an IT pro in security is going to be pretty critical to everybody's forward thinking. We have some great classes that support that. So I'm going to turn this over to Mike now. Mike has been doing this for about 20 years. He's a DBA. He's also one of our instructors, and he's has some deep experience in this. So Mike, go ahead and take it away.
Well, good morning, everybody, and a very pleasant good morning to you, wherever you may be. Our discussion today is about SQL Server's security model. We're going to be taking a very high-level approach to this because there's a lot more information than we can digest effectively in a half an hour. So we're going to just go over the highlights and give you the areas that you may want to drill down in more detail on your own. What we're going to be talking about, first of all, are some of the common threats to SQL Server data, SQL Server's security model, which is described as defense in depth, the different layers of security that we have to work our way through to come up with a good security model and how we are going to design them. First of all is getting into SQL Server. How are we going to authenticate users? How do we get people into a database? Who are the security principals in the database? And what are the database objects on which permissions are granted and denied? And then we're going to take a special drill down look into stored procedures and how they might be used to validate business data and how they are affected by the permissions that you grant. And then we'll finish up by taking a look at the different ways of encrypting data that you have available to you within SQL Server and in Windows. So these evil guys represent the threats that are out there. We hear about them every once in a while. We've heard about them with respect to SQL Server going back 16, 17 years.
We're not seeing the next.
They are out there.
Mike, we're not. Oh, there we go. Just took a little while for it to change. Go ahead.
Okay. Anyway, the threats are out there, and they are real, especially depending on if your SQL Server is on a private network. Maybe the threats aren't so real, but if it's exposed to the internet, even if you have a web server and a DMZ and then your SQL Server is behind a strong firewall, you may still discover that there are threats that are going to make your data vulnerable. So some of the ways that attackers have used over the years, I mentioned 16, 17 years ago, the first instances of SQL Injection were reported, made a lot of news at the time, more than anything else probably because it's Microsoft, but you know how that goes. SQL Injection is where you have, let's say you have a web form and users are typing into that form. Depending on how direct the connection is between that form and your database, users can put very long strings in there. They can, to try and overload, they can put actual SQL code in there. And that's what SQL Injection refers to, putting SQL code into a form. If the user knows the names of objects or just system objects, which are common to every database, and can successfully get that code past any kind of validation routines that you have set up, they might be able to get data back from that SQL Server that's privileged data. So SQL injection, it's very important that you validate your data. It's very important that you check for data of the right length and data of the right type, and make sure that it falls within your business validation guidelines before, at least to some degree anyway, before passing it off to SQL Server, even if you are doing the more detailed validation in the database. Error messages that give away too much information. Do you have object names, table names, stored procedure names as part of your error message? Do you have the database name? Or are you giving the user just enough information that they can either diagnose, if it's a business application, what does it have to do with the application more than the database? Or is it enough of an error that they need to go call the help desk, call support? Give them enough information to do that, but not too much so that a hacker may not be able to deduce information about your database from the error message. Elevation of privilege is something that we see all the time. Giving a user more permission than what they need. I saw it just recently with an off-the-shelf application that uses SQL Server as its database. All of the users using, the application itself is supposed to govern who can log into the SQL Server, but if you have a workaround way of getting past the application and into the database using a different client, you all of a sudden may find yourself able to read and write any table in the database. Making users a database owner just as a workaround when there's an error that people can't figure out, or even an administrator. A database owner is an administrator at the database level. Administrator is at the server level, but it's still more common than you might think to give users this privilege, even though you think, well, they're trustworthy, but the person getting in and impersonating them is not trustworthy. If you have a .NET client, an ODBC client, you are passing connection strings to SQL Server to log in. What's your Windows domain username? What's your SQL Server login? What's your database that you're going to be using? Any other connection string information that you might have? Connection string injection is when a user can take that information and put information in there, like replacing the database name with something else, replacing the server name with something else. You have passwords that may be too easy to guess. Everybody has probably, at least in a testing environment, used the word password as a password. Even with the uppercase P and the @A and $S's, it's still easy to guess. A lot of people do that. And back in the old days, you used to be able to look at people's passwords in SQL Server. They can't do that anymore. But in the early versions, you could, and it was interesting as an administrator to see just what people were using for passwords. A lot of them are easy to guess. Especially if you know the person, a spouse's name, things like that. So DNS spoofing, you are rerouting the client from the intended database server to a different IP address. Computer name routes to a different IP address. And luring, meaning you're doing something, an attacker is doing something to lure a user to a server other than the intended server. We'll be going through those last couple in more detail. Defense in depth is what Microsoft refers to as SQL Server's security model. It is a hierarchy.
Hang on just a second.
Nested containers.
We're still waiting for the, at least, there we go. Now it's come through. Go ahead.
So the defense in depth refers to a hierarchy of containers, and permissions are applied at each level, at each container. The SQL Server service account, we start out at that level. How is SQL Server logging into the domain, into the network? It's important that the SQL Server service account not be an NT, not be a Windows administrator, but only have the necessary permissions as a regular old user. SQL Server will need some special permissions as a service, but the SQL Server Configuration Manager or the setup program will give that service those permissions behind the scenes. You don't need to do that. So SQL Server itself is a regular old user on the network. Then within SQL Server, we have users logging in. They most likely will be Windows domain users, but not necessarily. How are they logging into SQL Server? Once they're in SQL Server, how do they get into a database? This is where a developer and administrators, security administrators, if your company has them, developers can all work to design a security model within SQL Server and within the databases to ensure that depending on what a user is, what their job is, what data they need to see, what data they need to write, they have the appropriate permissions and no more. So each SQL Server contains multiple databases, and users Bob and Alice may be able to get into one database and not another database. They may not be able to get into any other databases on the server, but be administrators in one database. Then once they're in, they are called database users, and permissions are granted to them as database users through users groups and possibly schemas. Schemas are object owners, and they are the last container of data. Schemas contain objects. Windows authentication is most likely the way you are going to be logging into your SQL Server. Through a domain, you have Windows authentication only is the default when you set up SQL Server. So you're going to be logging in as a domain user or a member of a domain group. You may also be logging in just as on a local computer account through Windows. You will need to have at least one administrator chosen during setup, a Windows domain user who is going to be the administrator. Does not have to be a network administrator. It can be just a regular old user as far as the network is concerned, but within SQL Server, they are an administrator. And then that person in turn can grant privileges to other users depending on, and grant the appropriate level of security to administrators and regular old users. You may choose a mixed mode authentication. Again, you can do this at setup time or later on down the road with the SQL Server configuration tool, where you permit both Windows logins and SQL Server logins. A SQL Server login is a separate login ID and password that's passed from the client to SQL Server. If you have SQL Server set up to receive it, the passwords can be as complex, for the most part, you can enforce rules that the passwords be as complex as Windows. Not all of the login features of Windows are available to SQL Server, but most of them are. And one of the most important ones, of course, is to enforce password length using different cases, using different types of characters to make sure that the passwords are complex enough. And this may be your only option sometimes when you are logging into SQL Server across networks, if you are going into a SQL Server across the internet without extending the domain through some kind of tunneling, some kind of private network. If you aren't in a domain, if you're in a work group, if you have two domains but they don't trust each other. One of the features of the SQL Server authentication is the SA login ID. This goes all the way back to the 80s in Sybase. SA stands for System Administrator, and SA is disabled by default in the later versions of SQL Server, but if you do enable it, it is an administrator, and it's going to have all of those privileges, and it's important that you give SA a password which is complex enough and only give it out to users who understand the importance of that login and make sure that it isn't misused. So once you log into SQL Server, what can you do to ensure that the communication back and forth between your client and SQL Server is protected? And one way is through encryption. Encrypted client-server connections are not enabled by default. You have to set up the appropriate certificates on the server side, trust those certificates on the client side, and enable your client.net application, for example, to use that certificate when logging in to establish the encrypted connection. Once you do all of that configuration and the clients are using the certificate to log in, all of that traffic between client and server is encrypted. Once again, important if you don't have another means of encryption like network encryption or something like that. Once you configure encrypted connections, SQL Server can be forced to use encrypted clients. Extended protection is a feature that I won't go into a lot of detail on, but you might want to check it out. It is not enabled by default unless you're forcing encryption, then it is enabled, and it helps protect your clients connecting to SQL Server from those two types of attacks, luring and DNS spoofs. So we have the different levels of security, and we're going to be drilling down through those levels and talking about how security is applied at each. The first one is getting into the SQL Server. The next one is using a database. When we use a database, we become a user in that database. What are databases? Databases are containers for schemas. Schemas own objects, and we set up storage by database. All the database files pertain to only one database. And we set up security within the database. Users who get into one database may not be able to even get into another database. Or if they can, they may have very different permissions in one database from another, depending who they are as a user within each of those individual databases. Users, when they request some kind of object access, are called, in the Microsoft language, security principals. There are lots of different types of security principals, well, 3 types actually. We have database users, the individual database user. We have database roles, groups of database user, and you can apply permission to an entire role, to one role, and it affects everybody within that role. We also have application roles. There are no members of an application role. When you define the role, there are no members in it. The members are applied dynamically as clients log in with the appropriate information to use that application role. Permissions are granted to users of a particular client application that supplies the application role information to SQL Server. A user in a database has no permissions by default. They can't do anything. They have to be granted everything. This is where the importance of a good security design comes into play. Schemas within the database, drilling down some more, are containers for objects. They're owned by a particular user. And you can apply permissions to the entire schema. And the objects that we're granting permission on within the database are tables, views, stored procedures, and functions. So the security principal requests object access. I want to select from a table. I want to insert into a table, select from a view. I want to call a function that returns something. I want to execute the code in a stored procedure. These are all permissions that must be granted. No user has that permission by default unless they're an administrative level type of user going in. So the 3 types of security principles again: database users, individuals, database roles, and application roles. Now there's one exception to database users being an individual, because remember that when we log into SQL Server, we can log in as a Windows group. One login ID for SQL Server can amount to hundreds of people when they log in as a Windows group. So you may choose to manage who has access to a database at what level of security through Windows by making users different members of different Windows groups. That user logs in, SQL Server sees which Windows groups they're a member of, and applies the permissions accordingly. So you are granting permission to one database user, but that may have the effect of granting that permission to hundreds of people who are members of a Windows group. A database user can also map to a certificate. We'll discuss that briefly at the end. Database role, a group of users, and the application role connecting through an application. There are special users and special groups in every database. The DBO user stands for database owner. That's the administrator within the database. There can be a guest user. It isn't enabled by default, but there can be a guest user. This is enabled in some of the system databases, most notably TempDB, the temporary database where you can create temporary storage for your objects that your application is using just for that session only. When you log off of SQL Server, all those objects are destroyed. So, and every time you restart the SQL Server service, that database is cleaned out. So it's strictly temporary, and there is a guest user there, and that permits any user through their application code to go into that database and do work. There is one group in every database called public, and everybody is a member of public. All users are a member of public, so any permissions that you grant to public amount to permissions that everybody in the database has, including guest. Schemas own objects. DBO is the default schema for any users coming in. The DBO user owns the DBO schema. They're two different things. They are distinguished from one another. Schema, the container, DBO user, the user. There are also special schema sys for system objects and information schema to get catalog information back from SQL Server. So the permissions that we are granting. We are granting the command verbs that we will be using with regard to permissions, either directly through Transact SQL code or behind the scenes with a Management Studio client or something that's running these commands. Grant, revoke, and deny. Grant permission. Revoke, take away permission that was previously granted. Deny, do not allow a user to do something. So let's say I have a group of users that I grant permission to, and then one of those individual users within that group I deny permission to do something. That one user is denied, everybody else in the group is granted. We grant permission to a user, to a role, a group, or a schema. And as I mentioned, granting to one user can have the effect of granting to a group when that is a Windows group that's logging into SQL Server. The permissions that we are granting and revoking and denying: select, insert, update, delete, which apply to tables and views; execute, which apply to stored procedures and functions. Permissions can be granted very granularly in SQL Server, right down to the row and column level. For example, you may want to encrypt a column and that contains sensitive data and give permission only on that. But this gets very complicated. There are ways of making your life easier. You can isolate reads by using views. Views can use search criteria to isolate the number of rows they get back and specify which columns they're getting back, so you can get a subset of the data in one or more tables by using a view, and then grant permission on the view, but don't grant permission on the table. And as long as the view and the table are owned by the same schema, the permission is implied. Permission to do what the view does is implied. The user does not need permission on the table as long as the view and the table are owned by the same schema. And then use stored procedures to validate your business rules. Once again, the same thing applies. Permissions are implied. So what are stored procedures? Stored procedures are either written in Transact SQL, or they are written in a .NET language, C#, Visual Basic, C++, and compiled into an assembly, a DLL. You can then load that assembly into SQL Server and call it as a stored procedure. So this may be something you do if you are want to do validation on your business data, make sure the data meets certain business rules at your database server rather than doing it at the client or in a middle data tier. Maybe you have some validations that you're doing in each of those places. So you can write a lot of code using stored procedures, and you can pass parameters to them, you can get data back from them, result sets back from them, and you're granting execute permission on the stored procedure. And again, if that stored procedure references tables, views, functions, other stored procedures, permissions is implied as long as they are both members, all the objects referenced are members of the same schema as the stored procedure itself. If you're going across schemas, if your procedure that you're calling is in one schema and a table is in a different schema, then it depends on the permission level of the grantor. If the user granting permission owns both of those other schemas, then SQL Server understands that you want that implied permission to be there. If the schemas are owned by different users, then you have to have explicit permissions. Grant permission on the table is granted explicitly in order for the user to use that stored procedure. Stored procedures can be signed and executed by users associated with the same certificate. So remember, a user can log into SQL Server through using a certificate, excuse me, a user in a database can map to a certificate rather than a login ID. That's the correct way to say that. A user can map to a certificate, and so if that's the case, certificates can be used to grant permission to users that they don't otherwise have by signing the procedure and signing the user with that same certificate. CLR procedures have other permissions besides just execute. You may, for example, write a CRL procedure that goes out and does something in the file system. In that case, they have their own permissions for what they can do, and a lot of that, of course, will depend on who the user is within Windows. Can they do that? So we're going to finish up today by talking about encryption a little bit. So the different types of encryption. We talked about the client-server encryption across the network. Within databases, one type of encryption we have are the ability to obfuscate stored procedures and functions. By default, when you create a stored procedure or a function and it's just sitting there, that code is just sitting there in the database, anybody can look at it. Anybody can look at that code. So if you want to prevent users from seeing that code, that if they know their way around the database enough to know where to go to find it anyway, you can encrypt that code and the stored procedure and the function will be unreadable. This is very common when you have off-the-shelf applications using SQL Server as the database, that they will encrypt their source code. You can encrypt down to the column level. Let's say we have a column that stores credit card data, social security numbers, other privileged information. We might want to encrypt all the way down to the column level so that not even an administrator can see what that data is. The only users that can will be users that have the certificate or key to unlock the encryption in that column. SQL Server 2014 offers the ability to encrypt backup files with the appropriate certificate or key, and this way you have the ability to copy backup files across the network without making that data vulnerable, have those files sitting out in the file system without them being vulnerable. And of course, Windows offers the BitLocker encryption of the file system, which you may choose to use to encrypt your SQL Server database files, but that encrypts by volume, and you might have your files spread across many volumes for load balancing and other reasons. So you may want to use BitLocker, you may not want to, but know whichever level of encryption that you choose. The more of these layers of encryption that you have, the more performance penalty that you might pay. And anyway, where your SQL Server database files are concerned, they shouldn't just be sitting out there. you should use NTFS permissions to restrict who can see those database files. Just the SQL Server service itself, however it's logging into the network, and administrators should be the only ones that can see that file. We have transparent data encryption, which Microsoft calls, which is also referred to as data at rest, which is the encryption of all the database files that a database uses. And these can be spread across many volumes, which makes it more feasible, easier to use than BitLocker. Now, even though the database files themselves are encrypted, data may be going back to the client in the clear unless that client data connection is also encrypted. So that's something to be aware of. Data at rest is just encrypted sitting in the files, not going back to the client. So there you have it. We have, that's just the 20,000-foot overview of security. There's a lot there, and we are going to be talking about it in more detail in the SQL Server System Administration course, and we hope that you'll join us.